Okay, question one on our assignment here, page 36. So if we take a look at this, of course, we're doing dihybrid. So we're looking at two traits now, two trait inheritance. So steps are basically the same. We're going to start with step one, which of course is coming up with a legend. So it says in guinea pigs, black color, capital B, is dominant to white, little b. So let's start our legend over here. If I have a capital B, doesn't matter what the other allele is, that's going to be black. And it's dominant to white. So if I'm going to have a white coat as a guinea pig, I have to have two little recessive alleles for B, and that's going to be white. But that's one trait. Now they're actually, and then they're showing us another trait. They're saying hair length is the other trait. So short hair is dominant to long. So capital S, line, doesn't matter what that other allele is. This will always be short. And the only way that we can have long hair is if I have two little s's. And again, make your little s's very different than your big ones there, just so you don't misinterpret when you're going through the Punnett square. And this is going to be long hair. So that's our legend. So basically the same thing. It's just that we did with monohybrids, but just we're doing with two traits now. So go through it. You really have to know the terminology to be successful in this unit. So you have to know what homozygous, heterozygous, all of that stuff means. So step two is underline the parents in the question and tell me the genotypes. So it says homologous for black, heterozygous for short guinea pig. Okay, there's one guinea pig right there. Now, often students will kind of think that those are two separate parents, but they're not, right? It's just that we're dealing with two traits. They're homozygous for the black, heterozygous for the short. So homo for the black, if we take a look at our legend, capital B is black. Homo means I have two alleles for that particular trait. So each trait still has two alleles or genes that represent that particular phenotype. One was given from each parent. And then they're heterozygous for short. So if I look at my legend, short is a capital S, but if I'm hetero, I must have a little s accompanying that. Okay, so that's one of the parents. So one of the parents, let's just put that below, capital B, capital B, capital S, little s, is crossed with our other one. So our other parent is white and long hair. Now there's no hetero or homo here, but you'll see why. When I look at my legend, white, I have to be little b, little b. So they didn't need to say homozygous white because that's the only way that you can be white is if both your alleles are identical little recessive B alleles. Okay, and long hair. Same thing for long hair. If I take a look at long, the only way I can be that is if I have two little s's. So again, they didn't need to tell you homo recessive or homo long. You just could see that with your legend there. So those are our two parents. And now we're going to start step three is our Punnett square. Now we're not going to do X's and O's like we did with monohybrids, but we're going to start every dihybrid Punnett square in this way. So just two lines intersecting each other. And what we're going to do is we're then going to determine what the gametes are going to be using the folding system. So what we do is we take the first gene of the first trait and we're going to foil that with the first gene of the second trait. So that is going to form one of their gametes. Okay, so that's going to be one of the gametes. And again, we don't know boy or girl, so we'll just arbitrarily put whoever on top. Now, what I like to put on top is the one that has more options, more different gametes, because I like working from left to right opposed to top and bottom when often I don't have enough space. And you'll see what I mean in a sec here. Now, take that first trait and you foiled it with the second trait or second allele of the second trait. And that's different, so we're going to show different gametes within the same parent. Okay, now how it works is you take the first trait, use the second allele of the first trait, and you're going to match it with both the other alleles of the second trait. So big B, big S. But you notice we already have that. So this is where we don't show repeated gametes. And this will save you a ton and ton of time. If you did do this, you're going to have to reduce the ratio at the end anyways, and you're going to end up with exactly the same answer, but taking up about 10, 15 minutes of time. And a lot of people get lots of anxiety for these problem solving questions on an exam because they feel like they're going to run out of time. This will help save some of that. Now, take that second allele of the first trait and match it with the other one. So big B, little s, but we notice we already have that as well. So these are repeats, and we're not going to show repeats in the same parent. Okay, so now we do that for the other parent. The other parent goes down the left side of the Punnett square. Going to match it up. Little b, little s. And if you notice, everything else now is a repeat. So while you're getting used to doing these type of dihybrid crosses, do this folding system with your arrows. After a while, you won't need to, right? You'll see that everything else is repeats, and you will be able to do it without having that. But when you're just learning that, use the folding system just so you remember how to get the gametes. And again, just a reminder what a Punnett square is, just like for monohybrids, we're isolating the gametes, but in this case, we're using the folding system. So this would actually be the sperm, right? This would be an egg. Okay. So now what we're going to do is we're going to bring these gametes together, simulating fertilization, and we're going to bring the B's together and the S's together, showing the dominant trait first. So big B is dominant to the little b, so we bring those together, and now we bring our S's together. Same thing, big S, this one comes over, little s. And just like we did within the box of the genotype of that particular offspring, we're going to put the phenotype as well. So go back and look at our legend. If there's a big B, this has to be a black guinea pig with a big S, short hair. Okay, then we do that for the other one. Again, simulating fertilization. If that egg gets fertilized by the other sperm, we're going to have a big B, little b, show dominant first, little s, little s. Okay, go back, look at our legend. Capital B, as long as there's a capital B, I don't care what this other allele is, this is going to be black. And two little s's is going to be with long hair. So we take a look at our ratio out of the two boxes, because we reduce this, right? We didn't show any repeated gametes. So this is going to be reduced as much as it can be, and it's going to be one being black and short, with a ratio one being black and long. Okay, and that is our answer. Okay, any questions with foiling or doing the legends or the Punnett square, just give me an email and we can address whatever issues you might be having. Okay, thanks guys.